Hi, let's have a look at a couple of more examples of integration by rule. So if our integration by rule looked like this, if I wanted to find the integral of a function that was a x to the power of n dx, then it's going to look like a x to the power of n plus 1 divided by n plus 1 plus c, our constant. So let's say we had a function that looked like this. So our function of x was 4 over x cubed. Okay. First of all, I want to write that with my x up here. So I can also write that as 4 times x to the power of negative 3. So what would the integral of 4 times x to the power of negative 3 look like? So first of all, I'm going to deal with my x. So it becomes x to the power of negative 3 plus 1 is x to the power of negative 2. Okay. My a is still 4, okay, and what I'm going to have in the bottom is I'm going to divide it by my negative 2 plus c. So that becomes 4 divided by negative 2 is negative 2, x to the power of negative 2 plus c. And if I needed to write that with a positive index, or similar to my original function, I could write that as negative 2 over x squared plus c. Let's look at another function. This time our function is going to have, say, a square root. So we're going to look at 3 divided by square root of x. And we want to find the integral, or we want to integrate this. So first of all, I'm going to write this in a format that makes it easy for me to do. So 3 over square root of x is the same as 3 over x to the power of half, or I could write it as 3 times x to the power of negative a half. So once I've got my x up on the numerator, okay, I can now easily integrate this. Same rule, so I'm going to write an integral of 3 times x to the power of negative a half dx. Okay. So my x is now, the power is raised by 1, so that becomes x to the power of negative a half plus 1 becomes a half. My a is still 3, and I'm going to divide it by my new power, so divide it by a half, and don't forget I need to add a constant onto the end. So that becomes 6 times x to the power of a half plus c, which if I rewrote it back in its original format is going to be 6 square root x plus c. I could always check that my solution is correct by deriving that. If I derive that and I come back to my original function, then I know that I've done my integration correctly.